For today's reading, we're going to discuss chapter 6 terms. This term list is primarily about water and chemistry and how water molecules work. So let's go through these. Absorption is a term that refers to whenever things are absorbed. For example, in this chapter, there's a lot of discussion about how water acts to absorb heat and also light. So absorption is whenever something's absorbed or taken up. Excuse me. Active sonar is a way that we can detect things underwater that uses sonar. And sonar is essentially sound that is produced and then it hits something like a fish or a rock, and then it bounces off. And knowing the time it takes for sound to return, we can tell how far it is and also how big it is. Adhesion is anytime things stick together. So if you glue things together with glue, that's adhesion. Aphotic zone is referring to the part of the ocean where light does not reach. It's called aphotic because it's the opposite of photic zone. Photic zone is where you do have light in the ocean. This is important because in the aphotic zone, there's no light, which means there's no photosynthesis, right? There's no ability of plants that live in the water to make energy. Atom is the building block of molecules, right? So it's really the core of an element. So if you look at, say, oxygen, oxygen is an element that is composed of atoms and also other parts that we'll talk about in a little bit. Calorie, you may have heard about calories if you eat food, and on the side it'll have how much caloric or calorie information is in there. Calories is a measure of how much energy something contains. So if you eat something that has high amounts of calorie, you can have a lot of energy, but if you don't have enough calories, your body is not getting enough energy. Chemical bond is anytime there's a connection. Could be a variety of different bonds. A chemical bond is a broad term that includes things like hydrogen bonds, ionic bonds, anytime there's an interaction between different elements. Cohesion is when things stick together. So kind of like adhesion, cohesion, things stick together. Compound is anything that is made up of multiple things. So for example, you can have compound elements where you have multiple elements together, right? Compound just means more than one. Covalent bond is a specific type of chemical bond. Covalent bond is where they share electrons. Deep zone can be used a variety of different ways. In this chapter, deep zone is referring to the deep part of the ocean. Degree is the unit that we use to measure temperature change. So right now, the temperature in my room, the air, is about 23 degrees C, right? So degrees is the unit that we use. Density, we've talked a lot about density already, is just how many molecules are in a specific area. So if you take a cube and you look at how many molecules of air in there, there's a certain number, right? And that's the density of that particular part of air. Density curve is when we look at changes in density, usually with temperature. So most things, when they get colder, get more dense. One exception to that is water. Water is a little bit different, and we'll talk about that in class a little bit. Electron are the parts of elements that are shared They are charged, right? So they're shared between elements. So for example, in a water molecule, you have two hydrogens and an oxygen, and they're sharing electrons. And that's part of the chemical bonds. Element is things like oxygen or hydrogen, carbon, right? The pieces of the periodic table that we talked about a few lectures ago. Freezing point is the temperature at which things go from a liquid to a solid. And for water, that temperature is 0 degrees C. Halocline. Halo refers to salt. Cline is anytime there's a rapid change. So you'll see cline in different uses in today's terminology. So it's just a rapid change in salt. And this happens in the ocean a variety of different places. And halocline is just that rapid change. So you have one part of the ocean, you might have a certain amount of salt, and then as you go deeper, it'll rapidly change. And that's a halocline. Not terribly important, but that's what it means. Heat is, in this chapter, the way we describe heat is how much energy is given off by something. So if you think about fire or a stove, it gives off heat, and that is energy being given off. Same thing, like if you go outside for a run or it's really hot, your body will give off heat, right? That's energy being released. Heat capacity is how much heat something can hold on to. Everything can contain a certain amount of heat. The best example, the example we'll talk a lot about in this class is water. Water has a surprisingly high heat capacity. And what this allows it to do, we've talked about this in the chapter 7 terms, is it helps buffer the temperature, right? So water, because it can hold so much heat, allows it to not change temperature as much as you would think. And that's important because it controls the temperature of the planet, right? So you don't want the temperature going hot, cold, right? You want it can change, but not so much, right? And that's because of water in the oceans. Hydrogen bond is a specific type of chemical bond. It forms between hydrogens, right? And a good example is water, right? You have two hydrogens in a water molecule, and hydrogen bonds are very weak, but when you have a lot of them together, they're very strong. The next two terms are actually related to water. The first one is latent heat of fusion. This is how much energy it takes to change solid water, ice, to liquid water. You can have 0 degree ice, and you can also have 0 degree water, same temperature. To change the type solid to liquid, that is the latent heat of fusion. That's how much energy you have to put into water just to change what's called the phase. I'm not sure if we'll talk about phase later, but solid to liquid water takes that amount of energy. Now, if you want to take that liquid water and change it to a gas, you can do that too, right? So that happens at 100 degrees C. So if you have 100 degrees C liquid and you change it to 100 degrees C gas, you haven't changed the temperature, but you've changed the state, right? Liquid to gas. That amount of energy is called latent heat of vaporization. Same concept as latent heat of fusion. Light. It's the part of what's called the electromagnetic spectrum energy that you can see, right? There's lots of energy around us, radio waves, television, microwaves, there's a lot of them. But what you can see is light. It's a very specific part of all the energy that exists. It's a strange thing to think about, but that's what it is. Mixed layer. Mixed layer is, in this reference, when it's talking about water, and different parts of water are mixing together, right? That's called the mixed layer. Molecule is anytime you have combinations of elements. So I mentioned the water molecule before. It has 2 hydrogens and an oxygen. Those 2 hydrogens and oxygen together make up 1 water molecule. Nucleus is the core, it's the center of an element, and it's composed of well, it depends on the element. It's composed of electrons, which are charged, neutrons, which are not charged, and protons, right? So protons are positive, electrons are negative, and they all kind of, it's hard to explain on a video. They all kind of interact together around the nucleus to form the element. Neutron, we just talked about, is part of an element. It has no charge, neutron, but it exists. Passive sonar, we talked about a little bit before with active sonar. It's similar to active sonar. You're using sound to detect things in the water. Photic zone, we talked about a little while ago with aphotic. Photic zone is where you do have light in the water and you have photosynthesis, right? That's photic zone. And that's important because that part of the ocean gets light and the plants there can produce energy, right? Sugar, etc. Polar molecule, an example of a polar molecule is water. Polar molecules have charges. So that means something can be positive or negative. Proton, talked about this a little while ago. This is the positive part. This is the opposite of an electron, right? And these are the core parts of an element, right? This is at what's called the atomic scale. Picnocline, again, a cline. Picno refers to density, right? We talked about density a little while ago. Picnocline is a rapid change in density. Now I have it in yellow because I do want you to know picnocline is very important because density in the world's oceans control how most of the water moves. So we have waves and currents and things like that at the surface, and that's good, and that moves a certain part of the ocean. But remember, the ocean is about 4,000 meters deep. Most of that water, that deep water, moves through differences in density. And that, when you have a very rapid change in density, that's called a picnocline. Refraction is anytime things refract or change their direction. So for example, if you take a flashlight and you shine it in air, the light goes straight, right? But if you have a glass of water and you shine the light into it, when the light hits the water, it bends because the light is moving at a different speed in the water, and it refracts and bends, right? And you can do the same thing with sound too. You can refract sound. Any type of wave you can refract. Refractive index is how refractive it is. So for example, if we want to see, the refractive index of water versus air, they're different, right? And we can measure that. Scattering is when energy is dispersed or moved. So for example, if you take, imagine I have a flashlight and I shine it in this room, the light will travel very far. But imagine I take a lot of dust, right? I make my room really dusty. Say I just, for whatever reason, I have a lot of dust in this room. If I shine the flashlight, the light is going to hit the dust particles in the air and scatter. And the light will not travel as far, right? Same amount of energy from the light, It just can't travel as far because the light is being scattered everywhere. Sensible heat, don't worry about it for this chapter. Shadow zone is part of sonar. So for example, if you're bouncing sound off of something, the sound doesn't reach the other side of what it bounces off of, right? Because I only have two hands, I can't show you this. But if the sound is coming and hits something and bounces off, there's still stuff over here, right? And this area behind it is called the shadow zone. You don't actually see it, you can't see it, right? Side scan sonar is a specific type of sonar that's commonly used nowadays on ocean research vessels. And it's called side scan because it goes out to the side of the ship, right? And so it's kind of, you can think like a scanner. If you ever scan a document, it's essentially like that, but it scans the bottom of the ocean using sonar. And it's very effective. It's a good way to measure the bottom of the ocean. SOFAR is in SOFAR layer, which I do want you to know. SOFAR refers to an area of the ocean where sound travels very quickly. And the SOFAR layer is a part of the ocean, depends on where you are. It's usually 100, 200, maybe 300 meters deep. And whales in particular go there to communicate because the sound can travel through that water very quickly because of the density. And because it's a layer, the sound travels in a more compressed area. So it's not like the whales are making sound into the ocean and it's scattered, right? It's focusing. It's kind of like, I'm not going to do it because it'll mess up the sound. But if you talk to a friend like this versus covering your mouth like that and talking at them, you're focusing your sound at them, right? And it's the same thing with the SOFAR layer. Sound is like light, but it's energy we can hear. So our ears have parts that detect sound and translates those waves into what we experience as sound. State can mean a variety of things. In this chapter, what state means is the situation of an element, what it's like. So you can say the state of water. Is it a solid or a liquid? Surface tension is a really interesting part of water that's created by these hydrogen bonds. If you ever see an insect walking on top of water, the hydrogen bonds of the water are very strong, even though each one is weak. Together, they're very strong. So an insect is able, some insects are able to use the tension created by those hydrogen bonds to walk on water like it's a solid. It's pretty cool. Surface zone, the top part of the ocean. Temperature is how we measure how much heat is in something. So right now, the temperature outside is probably 35 degrees C, really hot. And in the winter, it might be 5 degrees C, right? We measure how much heat, how much energy is in the environment. That's temperature. Thermal inertia is not terribly important, but it's essentially, if I have a block of metal or block of water and I heat it up, once I take away that source of heat, it will continue to increase its temperature, right? And that's called thermal inertia. Thermocline, it's the last cline, refers to temperature, thermo. And it's just like Picnocline and just like Halocline. Halo is salt, Picno is density, thermo is temperature. And thermocline is anytime you have a rapid change in temperature in the ocean or lake or river. Usually it's bodies of water that aren't well mixed, so like lakes and oceans. Thermostatic property, don't worry about it. And water mass is any mass of water, right? Could be an ocean, could be a cup of water, could be anything. Okay, well, that's it for chapter 6. And if you've got any questions, please let me know.